Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Advanced Transfer Learning and Few-Shot Learning, Maximizing AI with Minimal Data. Welcome to AI for Developers. Before we dive into advanced techniques, let's understand a core challenge. AI, especially deep learning, is like a super smart student that needs thousands, sometimes millions, of examples to learn a task well. Think of teaching a child to recognize cats. They need to see many different cats. Big, small, furry, hairless, before they can reliably spot a new one. For developers, gathering and labeling this massive amount of data is often the biggest hurdle and can feel impossible for many projects. Imagine you've already learned to play a guitar. If you decide to learn the ukulele, you don't start from scratch. Your knowledge of chords, rhythm, and music theory transfers over, making it much faster to pick up the new instrument. Transfer learning in AI works similarly. Instead of training an AI model from zero for your specific task, we take an AI model that has already learned a lot from a huge general dataset, like recognizing millions of everyday objects, and then transfer that existing knowledge to our new, smaller task. It's like giving your AI a head start. As a developer, you'll typically grab a pre-trained model. Think of it as a highly skilled AI brain that's already proficient in a broad area, e.g., image recognition. You'll then freeze most of its internal layers, the parts that learned general features like edges, shapes, textures, and only retrain the very last few layers with your specific, smaller dataset, e.g., distinguishing between different types of rare birds. This saves you immense time and computational power because your AI isn't learning fundamental concepts again. It's just fine-tuning its existing skills for your particular problem. Transfer learning is a game-changer for developers. 1. Less data needed. You don't need millions of examples. Hundreds or even dozens can sometimes yield great results for your specific task. 2. Faster training. Your model learns much quicker because it's starting from a place of existing knowledge, not from a blank slate. 3. Better performance. Even with less data, you often achieve more accurate results because you're leveraging vast prior insights. 4. Accessibility. It makes advanced AI achievable for developers and businesses without massive data collection efforts or supercomputers. What if you only have 1, 2, or 3 examples for your specific task? For instance, identifying a new, never-before-seen species of flower from just one photo. This is where few-shot learning steps in. It's not just about transferring knowledge. It's about teaching the AI to learn new concepts quickly from incredibly few examples. Think of a human child who, after seeing just 1 or 2 pictures of a zebra, can instantly recognize other zebras they've never seen before. Few-shot learning aims to give AI this learn-to-learn ability. Instead of just training a model on a big dataset, few-shot learning trains a model to compare examples and understand what makes them similar or different, even with minimal reference. For a developer, this often involves using specialized AI architectures, like Siamese networks or prototypical networks. These models are trained to look at a few support examples, your 1 to 3 images of a new object, and then compare them to a new query image to decide if it belongs to the same category. It's like teaching the AI to be a super detective that can find patterns and make classifications with very few clues. As a developer, you can start leveraging these powerful techniques today. For transfer learning, popular AI libraries like TensorFlow and PyTorch offer extensive collections of pre-trained models, e.g., ImageNet models, that you can easily integrate and fine-tune. For few-shot learning, you'll explore specific model architectures and frameworks designed for similarity learning. These tools empower you to build intelligent AI applications for custom image classification, anomaly detection, medical imaging analysis, and more, even when you don't have a giant data lab at your disposal. Start experimenting. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.